Good evening. Today we are going to discuss about assignment 8, that is autoencoders and variational autoencoders. So in this assignment, we are going to study regarding autoencoders, which are neural networks that are aimed to reconstruct the inputs. That means that will reconstruct the inputs. It is unsupervised learning. Unsupervised. It uses unsupervised learning. Here, it will reconstruct the inputs by decreasing the dimensionality of the input that we have given. That means that would we can see it over here. So we can see it over here. The how the input layer, and this is the bottleneck layer that using these particular inputs, that it created a bottleneck inputs. That means it has some correlations, so that it makes a different it will construct new inputs, it will construct new relations, and then it will give you an output layer. So by this way we can actually generate our models, and it will be easier to differentiate in unsupervised learning method. So it can be compared with the PCA, that is with the PCA, it actually compresses it actually decreases the dimensionality, but the accuracy and mm, the way that it works is very much easier in autoencoders. And the variational encoders uses some probability, like a probabilistic approach for same encoders. So let us dig into our assignment. So in our assignment, we are going to install the required dependencies and necessary files for like for running an autoencoder. So in from this we are installing Torch Vision, and so matplotlib, TensorBoot, so and NumPy. So and also we are getting the like autoencoders and autoencoders. We have downloaded all these things. After downloading all these things, let this our first exercise. So denoising the autoencoders, that is so DAE, denoising autoencoder, and VAE, that is that we have taken, that is variational autoencoder. So in the first exercise, we are going to learn about denoising autoencoders. In this, so first of all, we are installing all the necessary pip dependencies and also the packages. So all these are the packages and dependencies that we are going to install. And after installing all those packages, we need to load our dataset using the following code, that is cipher10 train. So this data set has been it's already present, and it will be given into the it is loaded. And after loading all the data set, we are going to visualize the data set, cipher10 data set. So in the cipher10 data set, after like we just need to plot the data set, and here we got the noise data set. So we are going to finish the encoder now. So we have got the noise dataset, and we need to denoise the dataset using autoencoder. So for this, so we are using next we are going to finish the encoder of denoising encoder. Like you'll be filling rest of the self encoder following sequence below. So this is the neural network. That means the networks that we are going to create. It has following layers, and using that layers we have generated a self encoder, and this encoder would be like so this encoder would be run, and now we are going to finish it. So first it will encode, and then we will decode. So we'll be encoding the input data, and then we need to decode the input data. So first we have encoded the input data using the given layers, and using the given layer, so we are decoding the data. And then next we are going to like build a model like a DAE, that is denoising autoencoder, using this the encoder that we have created and the decoder that we have created. We have a utility function that trains the data using cipher10 data loader. So this is the utility function, that is train underscore DAE is an utility function that would train our cipher10 dataset, and that would be these are the parameters, and this is the training output. After completing anything, we need to visualize the some like denoising some noisy images using this following code, using the following. So we have seen how it would be denoising the, like how, so from here to here, how it would be, it is denoising the data that we got. So this is an autoencoder. So from this data, it would be converting to this, and then it would be decoding it into this data. The next exercise is variational encoders. So in this, we are going to use not Cipher10. We are going to use MNIST dataset, that is we have 1 to 10 numbers, so 0 to 9 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have data loaders, MNIST train and MNIST loader. This segment, we are only going to consider about the training set, MNIST train. So now we are going to download the train dataset, and also MNext loader. So these would be using for downloading the required dataset, and we need to visualize the data using the following code. After visualizing, we would be getting these particular numbers, that is 8, 8, 2, 1, 4, some random numbers that in MNext dataset we are just taking four, uh, like from for four indexes, 0, 1, 2, 3, 4. And so next, in the next step, we are going to define the two linear layers of calculating the mean and standard deviation. So we are going to create two variables, that is self mu and self variant, and that are placed after self encoder. So in the encoder function, we are going to create self variance and self mean. Uh, so using the linear function, we have all created. It has a batch size of 128, and using the particular code, we are going to define all these things. Next, the decoder function. The decoder function, we got the layers like linear layer, LLU or LU activation function, and then at the end we have got sigmoid function. So after performing the decoder, we are using forward function uh, to process the decoder, and now we will train the variational encoder. Like for training the variation, we have already downloaded the VAE, variational autoencoder, and we are giving encoder and decoder functions that as a parameters. After that, we need to train the variational encoder. After training the variational encoders, we are going to visualize and generate a fake image. So this is the like a sample and random vector generate fake images and plot. So we have given the random random vector, and that would generate a fake image. So this is the variational autoencoder. Thank you.